this unit. The last topic of our solutions unit is colligative properties, and there are more colligative properties than what we talk about for this class. We're only going to touch on two of them that you're going to see in your real life most frequently, and that is freezing point depression and boiling point elevation. So the first thing that we need to do is figure out what is a colligative property, and then we'll actually do the problem solving from there. So when you look at your colligative properties, it is just a property that modifies the temperature. So it changes the temperature. That the state of matter change will actually happen. So if you have like freezing point depression, it changes the freezing point. If you have boiling point elevation, it changes the boiling point. And that happens when you put a solute into your solvent. So the picture that I have there is just water or something. I'm just going to call it water. And each of those little particles would be a water molecule. Well, the sunlight hits the surface of a puddle or whatever. The little particles on the surface move faster and faster and faster. They break away and they go into the gas state. Then you have the gas state that is free to hit the surface of the water. When it hits the surface of the water, because of intermolecular forces, it turns into a liquid. So you have this like free flow exchange from the liquid state to the gas state to the liquid state. Same thing happens with a solid. If this was a solid, it freely goes into the liquid state. The liquid that touches goes back into the solid state. And you have this free flow between the two states of matter. Well, what happens here is you're going to add your solute to your solvent. When you add the solute to the solvent, you have those extra little particles, the little solute particles, this like purple thing right there, that acts like a roadblock. And when it acts like a roadblock, it doesn't allow the particles underneath it to freely go into that gas state of matter or into that liquid state of matter. The opposite effect of that, when it's in the gas state, when it hits one of those particles, maybe it bounces away. So instead of being able to go between the two states of matter, it's going to get in the way, and when it gets in the way, it actually changes the temperature at which those particles can free, because it's going to take a different amount of energy to go from a liquid to a gas or a solid to a liquid. So with your colligative properties, the more roadblocks there are, the more effect it has. So when you have a different concentration, you're going to have a different temperature in which you either boil or freeze. So with your two colligative properties, like I said, you have boiling point elevation and you have freezing point depression. There are more than this, though. When you go into AP Chem and when you go into college, you're going to talk about more of them. However, we only talk about these two for this class because they're the most applicable to the real world and to your life overall. So what we can do with these is we can actually mathematically calculate the difference between the solvent's boiling point and boiling point elevation, and when you have a solution, the difference between the two. So we can actually figure out the new boiling point versus the original boiling point, and that's the difference between them. So you're going to actually find a change in temperature. A delta is change in, it's a triangle. So you're going to find the change in temperature. Same thing with freezing point depression. You're going to have the original freezing point, and then you're going to have your new freezing point with the solution, and you're going to look at the difference between the two. Again, you're going to find the delta T, the change in temperature. So the melting point and freezing point, those two occur at the same temperature, and then your boiling point occurs at a different spot when you're going from a liquid to a gas versus a liquid and a solid change. So this equation looks scary, but it's actually not that bad. We already know the little m. Little m is molality. Molality. Moles of solute divided by kilograms of solvent. We have a K value, which is a constant value that's going to be given to you. And then your delta T. Delta in math means change in, a difference in, and T is temperature. There's a little F there because this is for freezing point depression. Depression means that it goes down. Boiling point elevation means that it goes up. So freezing point depression, we want to know how many degrees Celsius it goes down in this case. So you're going to find your change in temperature, degrees Celsius, is equal to your K value times your little m. Your boiling point elevation, the equation looks identical because it is. The only difference, instead of an F for freezing, there's a B for boiling. Brain shattering right there, right? So you have your delta T, your change in temperature, that's degrees Celsius, is equal to your K value, your constant value that's going to be given to you in the equation, times your little m. Little m is moles of solute divided by kilograms of solvent. So when you get your answers on these, your delta T, either F or B, depending on freezing or boiling, it's going to tell you how much the temperature changes. So when you're finding how much the temperature changes, if it just says, what is the change in temperature, that's your answer. However, if it wants to know what is the new freezing point, or if it says, what is the new boiling point, you're going to take the original freezing point or the original boiling point, and you're going to either add or subtract. If you're finding the freezing point, you subtract from the original freezing point. If you're finding the boiling point, it's how many degrees Celsius it goes up, elevation, so you're going to add to that original boiling point. A side note, something to remember, the freezing point of water is 0 degrees Celsius. The boiling point of water is 100 degrees Celsius. So sometimes it assumes that you know that. I just wanted to make sure that I threw that out there, that you did know that the freezing point of water is 0, boiling point of water is 100. So with your math problems, I have 3 of them that we are going to do. And with my 3 math problems, we're going to use our document camera here so I can write on it. And it says, while antifreeze protects a car from freezing, it also protects it from overheating. Calculate the freezing point depression of a solution of 100 grams of ethylene glycol in 0.5 kilograms of water. The K value is 1.86 degrees Celsius. So things that I need to know before I do this problem. My delta TF for freezing point. Usually I don't even write the F, but I'm going to write it this time for you. Is equal to your K times your little m. My little m is equal to moles of solute divided by kilograms of solvent. So this is what gets plugged in right there. So on this problem, it says calculate the freezing point depression. So I'm solving for that. When I take my K, 1.86, times my little m. So I need to find my little m. They gave me the data to find my little m, I just need to do so. So it says that I have 100 grams of ethylene glycol in 0.5 kilograms of water. So my little m is moles of solute divided by kilograms of solvent. Water is my solvent. I need to find my moles. To get my moles here, I'm going to take my 100 grams of my ethylene glycol, and I'm going to use my molar mass, so C2H6O2. So 2 times 12.01 plus 6.06 for hydrogen, and then plus 32. So my molar mass here is 62.08 grams for the mass of 1 mole. So 100 divided by that answer. I started with 1, 2, 3 sig figs. So I have 1.61 moles, which is going to go here. So I have 1.61 divided by 0.5. With 3 sig figs, this answer right here is 3.22. So I took this and put it up there. So this number went here, and then like I'm working up the chain here. So my delta T is equal to K times my little m value. So K is 1.86, little m is 3.22. 1.86 times 3.22. This answer needs 3 sig figs, so I get 5.99. My delta T value is degrees Celsius. It's the change in temperature, and you're finding it in degrees Celsius. So that right there is my answer. That's my change in temperature. Now there is a second question here. It says, what is the new freezing point of water if the original freezing point was 0 degrees Celsius? So you take your original and you subtract when it's freezing point. Boiling point you add, freezing point you subtract. So my original was 0, so original. My new, or my delta T, so minus 5.99. So when I do this, this has 1 decimal place. This one has 2 decimal places. So my answer can only have 1 decimal place. So that means that my new freezing point is -6 degrees Celsius. You take your original and you subtract off your delta T. This made it go up. The 59 had to go to 60, so that's why I rounded for sig figs, because when you're adding and subtracting, you look at the number of decimal places. So this did ask 2 different questions, and I answered both of those questions. Now this one says, water with sugar added to it will boil at a higher temperature than pure water. How much will the boiling point of water be elevated if 100 grams of sucrose is added to 500 grams of water? The K value is 0.52. So again, I have delta T is equal to K times my little m. Little m is moles of solute divided by kilograms of solvent. My K value is already given to me right here. Right here, 0.52. So I need to find my little m before I can go further. So this says that I have 100 grams of sucrose added to 500 grams of water. My kilograms, my water, is 0.5. 1, 2, 3 times I'm moving my decimal place for my kilograms. My 100 grams of sucrose needs to go to moles. So I need to find the molar mass of that compound right there. So I'm going to take 12 times 12.01 plus 22.22 plus 11 times 16.
All right, pardon this interruption, teachers and students. The time is now 12:48. We are complete with testing for the day, so I'm turning the bells back on. We will get our 12:55 bell that will release us, moving D-lunch back into 6th period, or everybody into 6th period. The relocations are all
This has
off,
3
so everybody is back
sig
to normal
figs.
for our 6th and 7th period. Again, testing is complete. The bells will be back on, so please.
So this is
follow the
0.292.
bell system as it rings.
Sorry about the announcements.
Nonetheless, good day. Tomorrow, got a lot going on. Make sure you know
0.292 divided by 0.5.
10th graders and anybody that missed or any retesters that are involved in that. Outside of that, the other ones you're at home. Make sure you engage in your attendance.
So you have 0.584 little m. So I'm going to take K times 0.52. Sorry, he wasn't supposed to be doing announcements during class. 0.584 is going to give me my delta T for my change in temperature. So I don't know if you heard me or not, but I found my moles. I took my moles divided by my kilograms, and that's going to give me my little m times my K value. So I have 0.52 times 0.584. This one has 2 sig figs, that has 3 sig figs, so 2 sig figs is 0.30, and that is degrees Celsius. It only asked me to change my, to find my change in temperature. How much will the boiling point of water be elevated? So I don't need to do anything else. I'm not adding, I'm not subtracting, because it's not asking for the new boiling point. It just says what is the change in temperature. So that's my answer right there. Now this one, it says how many grams of iodine is I2, would have to be dissolved into 1,620 grams of ethanol to lower the freezing point by 0.25 degrees Celsius. The K value for ethanol is 1.99 degrees Celsius per mole. So with this one, it gives me my change in temperature. It also gives me my K value. I'm going to solve for little m first. Once I get my little m, then I can get this how many grams of iodine part of it. Because remember, your little m is equal to moles of solute divided by kilograms of solvent. They gave me my solvent. So this is 1.62. There wouldn't be a 0 on there, so it's just 1.62 for my kilograms. I would have to solve for moles this way. Some people can do the algebra and solve for moles and then take your moles back to grams. Some people can't. So typically what I tell you is just solve for little m first and then set your little m is equal to moles per kilogram. So either way, whatever mathematically works for you, I'm going to solve for little m today. To get little m all by itself, I divide both sides by 1.99. So 0.25 divided by 1.99. That has two sig figs, so I get 0.13 little m. Now once I have my little m, then I have my moles of solute divided by kilograms of solvent. My kilograms of solvent, again I moved my decimal place up here to give me 1.62. This is where you can use your triangle if you like to use the triangle. Moles per kilogram. I am solving for my moles here, so I'm going to multiply them, or you can multiply both sides by 1.62. Again, whatever algebra works for you, it's up to you. So we get 1.62 times 0.13. With two sig figs, I get 0.21 moles of iodine. I'm not quite done because it's asking for grams. All I'm doing is I'm working backwards through this problem. I'm getting my little m first. Once I have my little m, then it gives me moles. I'm going to take my 0.21 moles and convert it out into grams. Again, iodine is I2, so you have 126.98 times 2 is 253.96 grams. So 0.2 times that answer. Again, I have two sig figs that I'm working with, so that gives me 51 grams of iodine. So on this problem, because it was asking for part of the m problem, the molals, I solved for little m first. I got that all by itself. Once I got my answer for little m, then I took my little m is equal to moles per kilogram. I got just my moles, and then I converted moles to grams just like we had been doing. So as long as you break this up kind of step by step, these are not really that difficult. It just kind of looks intimidating when it says how many grams, because people go, oh, I don't know. And then they try to set it up with like the 0.25 is equal to 1.99 is equal to your moles per kilogram, and they would have something like that. And then they try to do like crazy algebra with it. So if you can do it this way, go for it and get your moles and then convert moles to grams. Or just think about this as just a little m and then use that for your little m. So whatever works for you, it is totally your call in terms of the math. I hope you guys have a great day. We are done with this unit.